So, the previous class we have discussed this, now we will consider some example to start with, as I told you. So, let me erase some part. Suppose it is given U okay. I am taking an example from Paris book. It is given W equal to 12. 12 bits constitute one word, and you are parallelizing by J, and J is 3, which means out of every 12 bits that constitute a word and they are coming serially because it is a bit serial system, you take first 3, you form a first digit, they are parallel. Next 3 again make them parallel, that is next digit, so on and so forth. So, every word has got 4 digits, okay, each digit of size 3, 4 digit cycles. So, Lth word will be, as you know, Lth word cycle, you will have 1 digit, another digit, another digit. So, this digit will have 3 points, okay, these 3 points, they will have 3 points, 3 and 3, all right. So, first digit cycle will be what? W prime L, I told, W prime here is 4. So, 4L plus 0, 4L plus 1, 4L plus 2, 4L plus 3. In 4L plus 0, 3 bits of the Lth word, sorry, they will be parallel. In 4L plus 1, next 3 bits, okay, will be parallel, and so on and so forth. So, 4L plus 0 is the first digit of the Lth word, 4L plus 1 next digit cycle, then 4L plus 2 next digit cycle, and so on and so. This is what is given. That is W is 12, I have to unfold by 3. So, W prime is 4. Right. So, since this parallelized by 3, U will be copied 3 times, U0, U1, U2. V will be copied 3 times, okay, and it is given, this is closing not only at once, it is closing at these indices. This is 4L plus 0 was the digit index, but in terms of bit position, this was 12L, isn't it, because every word cycle has got 12 bits. So, first one was 0 to 11, next was 12 to 23, then 24 to 33, 24 to whatever. Okay. So, 12L plus 0 up to 12L plus 11, last one is 12L plus 11. When I write in red here, these are the bits, 12L, 12L plus 1, L plus 2, L plus 3, like that. This is the digit index, digit cycle index, 4L plus 0 for the Lth word. It is the 4L plus 0th digit cycle, 4L plus 1th digit cycle, and like that. But in terms of bit indices, 12L, 12L plus 1, 12L plus 2, up to 12L plus 11, okay, because every word cycle has got 12 bits. I am dividing them into blocks and making them parallel, that is why blocks are coming in terms of 4L, okay, because total is 12, I am taking 3 at a time. So, 4 into 3, 12. So, I have got 4L, 4L plus 1, 4L plus 3. But in terms of bit actual bits in the bit serial system, 12L, 12L plus 1, there is 12L plus 0, 12L plus 1, 12L plus 2, dot 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 up to 12L plus 11. And it is given that at certain positions within this cycle, certain positions, not only once, because earlier I considered only once, now certain positions given as 12L plus 1, 7, 9, 11. At these points of time, the switch closes, otherwise not. So, earlier I considered only one point, WL plus U, WL is 12 here. So, WL plus u either 1 or 7 or 9 or 11. So, whatever I did for one case WL plus u, that I have to do for 1 u equal to 1, separately for u equal to 7, separately for u equal to 9, separately for u equal to 11. Okay. So, start with 12L plus 1, take j common, j is 3. Okay. So, 12L, 4L, then divide 1 by 3, quotient is 0 and whole 1 is left out as remainder. So, in 4L plus 0th digit cycle, that into 3, and which point within that? Not the starting 0th point, but point 1. I have got 0, 1, 2, 0, 1, 2, 0, 1, 2. So, 1, that means u 1, that will get connected to V 1, no delay in this path. So, u 1 will go to at what clock? 4L plus 0, that digit clock. This is digit clock, digit. Sometimes I say cycle. Okay. 4L plus 0 digit clock. Next index is 12L, 12L plus 7. Again take 3 out, 4L, divide 7 by 3, so you have got 2 and 1. So, 4L plus 2, at 4L plus 2 again u 1, because remainder is 1. So, this point 1 which goes to u 1, u 1 will go to V 1. So, e 1 goes to V 1 not only in 4L plus 0, that digit cycle, also at 4L plus 2 this digit cycle. So, 4L plus 0 and 2. Then question 12L plus 9. Take 4 common, sorry 3 common, I am sorry. Take 3 common, 4L, divide 9 by 3, so fully divided 3 and 0. So, at 4L plus 3, that digit cycle u 0 connects to V 0. So, u 0 will go to V 0 at 4L plus 3. Okay. And last one 12L plus 11. So, u 2 goes to V 2 at 4L plus 3. All right. Next example, another one. Now, I will introduce delay. This is 2D delay here in this age. There is a switch either closest to this or closest to this. So, in some cycles this path this is a bit serial system. So, within every watt cycle at certain bit points or bit clocks, this exists, this remains connected, this does not exist, this remains disconnected and vice versa. It is given, so let me show by dot dot dot, it is given that our watt cycle here is 6. Okay. So, it is given a fully bit serial system where original watt cycle was 6. So, 6 bits constitute 1 watt. Now, using the faster clock, 6 bits are coming serially down them. Okay. Every 6 bits constitute 1 watt, every 6 bits constitute 1 watt. Clock is 6 times faster than the original input clock, because in one input clock, input watt clock, all the 6 bits are packed one after another. Anyway, that is a side story. So, this is a situation and the switching indices are, obviously here as you know Lth watt cycle will be having what points? 6L plus 0, 6L plus 1 up to 6L plus 5, isn't it? Because total size is 6. So, out of these bits points, this will be closing at 6L plus 1 and 5. Okay. And the other side will be closing at the other indices 6L plus 0, 2, 3, 4. Now, here you see, so I have to unfold by j equal to 3. So, 3 bits will from one digit cycle, 3 another digit cycle. So, W prime is 2, 3 into 2 is 6. Okay, so, this will be 2L plus W prime L plus 1 like that. So, this is 2L and this is 2L plus 0, this one in terms of digit cycle and this is 2L plus 1. Here I will have 3 bits, here I will have 3 bits, these 3 bits parallel, these 3 bits parallel. So, 12 plus 0, one digit cycle, next digit cycle 12 plus 1. Okay. I have to unfold it by j equal to 3. Now, you see here I have got a delay 2D. Okay. So, what I will do? I will introduce a dummy node which only takes data and gives, does nothing else. Okay. So, what I will do is I will introduce a node called dummy, DUM, dumb for dummy. So, dummy node takes from A and gives it to this side. So, now you see that if there is an edge between dumb and C and this edge has no delay, delay I have kept to the left of dumb between A and dumb. Okay. So, now I unfold by a factor how many? Unfold by a factor j equal to 3, because 3 bits will be kept parallel and 2 digit cycle 12 plus 0, 12 plus 1. So, now let me, so A0 A1 A2, then B0 B1 B2. Okay. DOM 0, because there will be every node will be copied parallelly 3 times, because j is 3. First consider the edge A2 DOM, there is no switch, it is a normal usual unfolding. You know A0 will go to, I believe you know it by already, A0 will now go to this one, under the same system cycle no delay. A1 will go to this place with one system cycle delay, A2 will go to this with one system cycle delay, because 2D, all right, A2D DOM. So, 3 bits it is unfolded by 3. So, if this, just to remind you, just to, we had this situation of unfolding. Okay. Remember this thing in unfolding, Kj plus 0, Kj plus 1, Kj plus 2. This if you go to the right by 2, 1, 2. So, from 0 you go to 2. That is why A0 going to dump 2 with, but no system delay because under the same umbrella. But Kj plus 1 will go to the starting index here. So, one system cycle delay, and from 1 it will go to index 0, that is what, and this will go to index 1. Okay. This is pretty simple, this we already know. I did that just to remind you about what we did. All right. Now, consider dump to C. C also will be copied 3 times. So, C0, C1, C2. All right. Now, consider 6L plus 1. This between dump and C, this edge, it is closing at 6L plus 1, 6L plus 5. So, start at 6L plus 1. 6L plus 1, take J common, 3, 2L plus, divide 1 by 3, that is 0 and 1. So, 12 plus 0 is digit cycle, dump 1 will go to C1, 1, and there is no delay here. So, it gets corrected, dump 1 goes to C1. So, dump 1 will go to C1, C1 actually I am not connecting, I am putting a switch here, because very soon you will see that this is a switch, this is getting connected at 12 plus 0. So, 12 plus 0 is getting connected to C1, dump 1 getting connected to C1 at 12 plus 0. Take the next one, that is 6L plus 5. Take 3 common, that is J. So, 2L plus 1 and then 2. So, dump 2 will get connected to C2 at 12 plus 1. So, this will get connected to C2 at 12 plus 1. Now, those are the two switching indices between dump side and C side. Other are from B side to C side. So, now next we consider the other ones from B side to C side, 6L plus 0. 6L plus 0 take 3 out, 2L plus 0 plus 0, right. So, 12 plus 0, B0 goes to C0. So, B0 will go to C0 at 12 plus 0. So, C0 has a switch, this side is at 12 plus 0. Next one is 6L plus 2. Take 3 out plus 2. So, B2 goes to C2 at 12 plus 0. So, B2 goes to C2, okay. B2 goes to C2 at 12 plus 0. Still some more are left, 6L plus 3. Okay. So, at 12 plus 1, B0 goes to C0. So, B0 goes to C0 at 12 plus 1. Okay. And last one is 6L plus 4. Take 3 out. So, 2L plus 1 plus 1. So, at 12 plus 1, B1 will go to C1. So, B1 will go to C1 . Oh, just correction required, sorry. This is showing 12 plus 0 at 1. So, downward should go to C1 at 12 plus 0. So, my convention is upper side is 12 plus 0, lower side is 12 plus 1. Upper side 12 plus 0, lower side 12 plus 1. If I want to stick to that convention, let me just interchange the two. So, downward going to C1 at 12 plus 0. So, 12 plus 0. This is my convention. Upper side of the switch 12 plus 0. Lower side it connects at 12 plus 1. If I want to stick to that 12 plus 0, and now I am getting the 12 plus 1, again B 1 goes to C 1. So, that is why B 1 goes to C 1 at 12 plus 1. Now, you can simplify it. Firstly, you see this dumb 0, dumb 1, they do not go anywhere, they are not of any use. So, these edges you can remove because they are not taking you anywhere. So, therefore, I am sorry, dumb 1, sorry, that edge, this edge. And other dumps you short circuit. Okay. Because what does a dump do? It probably takes something and gives the same thing. It does not do any processing. I just created the dummy node. So, this will be, again you just sort it. Another interesting thing you see, B 0, it is connected to C 0 in both 12 plus 0 cycle and 12 plus 1 cycle, in both the cycles. Okay, 12 plus 0 and 12 plus 1. That means it is always connected. So, I will have a direct connection between B 0 and C 0. Okay. So, that is all you have. This is unfolded structure. Okay. Now, we should consider how to convert this into, how to apply this to the bit serial stuff, the bit serial ladder and unfold it. Remember, we had this bit serial ladder. Maybe I can go back to that page and it says my drawing. This was the bit serial ladder, right. So, if you want to draw a DFG, this will be one processor node. It is coming from a source node called A, and these bits are coming from another source node called B, A, B. Okay. And this is another source which is permanently holding binary value 0. So, from A there is a edge going to source node, a adder node, adder is summer, you can call it S. So, from a source node A which is delivering the A bits, it will go, and edge will go to S node. From a source node B, another edge will go to this S node. Okay. From a source node Z, Z stands for 0, which holds binary 0. There is an edge which goes to the summer, but through a switch. Switch closes only once per nth watt clock, that is at 4n plus 0. And from summer S output an edge comes. So, there is a loop with a delay, but this edge has a delay plus this has a switch, it does not exist always, and this goes to the output node, maybe R, capital R for result. Okay, this is the situation. Okay. So, you can then draw DFG for it. S for that adder, A for the source node of the bits A, B, A0, A1, A2, that bit, those bits. B is generating the B bits. This is producing the result in R going to the sync node. There is a Z node, but there is a switch. Z node is connected at 4n plus 0, and this is connected the carry by a delay. at 4n plus 1, 2, 3. Since there is a delay, I will put a DOM here. This is DOM. So, between DOM and this S there is no delay, there is only switch. Now, unfold by four and unfold by 2. If I unfold by 4, we will see we get back the original structure, okay, original bit parallel or structure. If you unfold by 4, then what is happening? A will be copied 4 times, B will be copied 4 times and like that. Okay. So, we may have A0, instead of making them vertical A0, A1, A2 like we do U0, U1, U2, I am making them horizontal, that is all. Or maybe I erase this here. A0, then here will be A1, A2, A3, but let me also do for B0. Here is S0, every node will be copied 4 times, R0 and W also will be copied 4 times, Z will be copied 4 times. So, Z0, DOM 0, okay. So, I am unfolding by j equal to 4. To start with, unfolding by j equal to 4. Okay. Similarly, we will have A1, and lastly, I am running short of space here, A0, A1, A2 done, I will have A3, B3, S3, R3, DOM 3. Now, first S2 DOM, this is one delay. Okay. So, if I unfold by 4, these are the 4 points. You are delaying by what? So, if you start from here, you are going here only under the same cycle. So, no delay, okay, which means S0 will go to DOM 1. So, this will go to DOM 1 without any delay. S1 will go to DOM 2 without any delay. S2 will go to DOM 3 without any delay. S3 will go to, last one will go to DOM 0, but with a delay. I am moving to the next cycle. From here I am going to here, right. So, this will go to DOM 3 with one delay. All right. It is very simple. AG, because this edges A to S for example have no delay. So, A0 will go to S0, A1 will go to S1 and so on and so forth. So, A0 goes to S0, A1 goes to S1, A2 goes to S3, similarly. S2R also no delay. So, S0 goes to R0, this is very trivial. All right. Then started the switching things. W equal to 4, J equal to 4, meaning W prime equal to 1, okay. So, start at this indices 4n plus 0, 4n plus 0, you take 4 out, W j into W prime L, W prime is 1, okay. So, 1 into n plus 0 by 4 0 plus 0, okay. So, at nth, see now nth watt cycle is same as nth digit cycle, because all the 4 bits are made into parallel, okay. So, nth watt cycle, whole watt cycle is the digit cycle. So, nth watt cycle has got only one digit cycle, which is the nth, okay. So, nth digit cycle, who will get connected? 4n plus 0. So, Z0 will get connected to it will get connected to whom? S0. So, this will get connected to S0, nth watt cycle, and nth watt cycle means the whole of the watt cycle, no switching is required. Whereas, if you see these edges 4n plus 1, so say dumb output, dumb 1 will go to whom? In the nth watt cycle, and therefore, equivalently nth digit cycle, dumb 1 will go to S1. So, dumb 1 will go to S1, no switch required, because the whole watt cycle is the digit cycle. Now, I do not have to switch, okay. Dumb 1 goes to S1. Similarly, dumb 2 goes to S2, dumb 3 goes to S3, and here this goes here with 4n plus 0, that is for this side, Z side. So, Z0 goes to, the index is 0. So, Z0 goes to S0, okay. And you see this does not go anywhere. So, no need to have this point, this at all, okay. So, this is your full adder, because you see A0, B0, these 2 bits. What does this node do? It takes the LSB only. 4 bits are packed and made parallel. So, LSB 0th bit is given to this source, 0th bit is given to, so LSB come, of binary 0 is always giving us initial carry, result goes out, new carry goes. Now, dumb you short circuit. So, it goes to S1, this Z1 has no meaning. Okay. So, I can erase them now, all the dumps I can short circuit. So, A0, B0 initial 0 carry, result new carry goes in, as this carry goes in as carry input A1, B1, okay. Then the next 2 bits, because A0, A1, A2, A3 in any cycle, this will go here, A1 will be, small a1 will come here, small a2 will come here, small a3 will be coming here, same for B. So, now in the same cycle then, because they are parallel, okay, A1, B1 get added here, all right, A2, B2 get added here, they all get initial carry, the carry from the previous addition, and you get the result. This is nothing but your 4-bit full adder. Interesting thing will be J equal to 2 case, when from bit serial we convert it into a digit serial adder with digit side equal to 2. So, that will be done in the next class. Thank you very much.